Hello, and welcome to Testing a Smart Contract. My name is Jens Scheel Nellemann, and I'm a software developer at Partisia in the Smart Contract language team. First off, what is a smart contract? A smart contract, if you look it up at Wikipedia, it's defined as this computer program or protocol where the execution of it and control is automatic, so there is no interaction from a human side, and in this way we can have legally events and agreements being executed by our smart contract. However, on a blockchain it's a bit different, since there is no such thing as truly automatic. In some way we always need to start behavior where we are checking for different parameters such that we can actually change a state. Also for a blockchain we have this deployed contract where the state is final on the state for the current block, and the only way to interact with it is through already predefined actions. So this means that we have to call the actions to interact with our smart contract, and also this means that whenever we are changing states and it is confirmed as in the new block, this means that it's final and we cannot reverse it. This also means that we need to have a lot of guarantees for the actions that we are doing. We need to make sure that there are no holes where we can exploit the contracts and subtract sums from other people. And we've seen a lot of different examples, something as the Akku Ethereum NFT, the Skynet is Finance Treasury, different DAOs, all of these different kinds of exploits in the smart contract where the security and the behavior of the smart contract is not understood well enough, or there is an exploitable way of doing it such that we cannot see exactly how it is working, but somebody else knows exactly how to call it or interact with it such that they can exploit the contract. So there are different ways of making certain our code works in the way we want to be. So a smart contract, we need to in some way have a review of it. Many do this in a bug bounty. You can also have documentation that describes the behavior in this way, such that when people are doing review, they can agree upon that it is actually doing what it says in the documentation. We can also do something as 100% code coverage, wherein we are writing tests, such that we are actually covering the entire code space in some form of testing. And we can also do static testing in the form of having different programming paradigms, such as which programming language we are using. Is it statically typed? As we do in Partisia, we have Rust as our smart contract language as the subset of. If we define behavior as this ladder, where we are more certain the further we go up the ladder, then first off we have happy and lucky, which is we are not going to test anything, we're just going to be very happy, and maybe if we're lucky there are no ill-defined behavior that somebody can exploit. However, if we want to do a bit more, what we can then do is we can start and test each part of the contract. For example, we can test each action for a contract and how it affects the state of the contract. So how will we do that in the case of a simple auction contract, such that we are not transferring funds to people who are not supposed to have them, and we're not starting an auction, or we are not ending an auction before time, and all of these different kinds of interactions we can do. So we have a simple contract, we can start it, we can bid on it, and we can then claim if we're not winning. We can also claim our winning in the end, and we can then end the auction. And then we have two token contracts, one where we are the selling token, which is the one that we want to sell something of. So I want to sell some Bitcoin, or I want to sell some Dogecoin, and then I'm bidding with Ethereum, so that's my bidding token contract, and we can transfer between accounts. So I'm transferring to the auction contract state, and it is then having this internal state such that you cannot claim unless you are not the winning bid, and if you're the winning bid, then in the end you can claim the selling tokens. So one of the ways of doing this right now for Partisia is doing it through the manual unit testing, and we can do this using the testnet dashboard. We deploy an auction contract where we have some owner, and we have the start time and the end time of the auction. We have how much are we selling, and then what is the token contract state that we're selling it for, and currently who is the highest bidder. Since we have just started it, nobody is the highest bidder. So what we do now is that we send an action from a different account where we send a bid amount for 100,000. And now we can see that the highest bidder is now the one we sent with. So we can now confirm that when we bid, and we bid with the highest bid, we are becoming the highest bidder. And if we enter the contract, I would then receive the selling tokens. Now I can try and reconfirm that if I now bid with a higher bid than the last one, then I will become the highest bidder. So I can now send that off on the testnet and then see that I will become the highest bidder on the contract state. Manual testing, it's very nice for testing quick behaviors and not very long sequences of actions. It's running on the testnet, which is actually a test deployment of mainnet. And it behaves like mainnet in this way, so this is actually an integration testing of our auction contract. However, since that it is the human who are inputting, and we always have to go through all of the steps, then it becomes harder to repeat. It's prone to errors. It's not very good for continuous integration, where we are working with these inputs as being something that I have written down in a document that you should sit down and put into the testnet. So we like something more automized. So for the Rust unit test, we can do a bit better. We can actually automate this process of interacting with the contract state in the form of actions. So first off, we need to create some form of setup where we are creating the values, we're creating the contract state. Then we create our bidder with the address info needed for him. And then we create our context for the bid. Now we call our bid, and then we get the events back, and we also get the current bid state there would be, so we get a callback. And now we can look at it and see, oh, does this actually match the current bid state that it should? And is it actually matching our callback state? We can also see that the events that it has created is of length 1. This is the transfer from the token contract from our address to the contract state, to the contract address. So now we can go on and look at what are these events, and we can create our events that we want to match with the events created by our action. So now we're going to create our event. We are going to create an event group. Then we're going to expect some form of payload, the transfer payload needed for the token contract. And then we're going to create a callback payload, which is what are we actually expecting to be called when this action returns. And now we can create an expected event, and we register the callback for it. And now we can assert that these two events are actually equal to each other, since the bytes should be equal. And this way we can create objects in the expected form that we require, and see if our actions are actually returning the required form. So this is very nice, and we can use this in an automized way. However, there are also some problems, but it's very nice because we're testing it directly with the contract code in the Rust repository, and we can also run Rust coverage for it. However, between contracts we have no form of interactions. Everything is also defined in some form of just bytes we are giving to our actions, and it's all defined in the test still. There are no outside parameters, and we're not using a blockchain for this. So there is no real integration into the blockchain. So we can do a bit better in the form of certainty of behavior, since we can do integration testing. Integration testing is about testing inside of the environment you want, testing with it. And in our case, that's testing directly with contracts deployed on a blockchain. However, we also want to do integration testing where we don't need a fully deployed blockchain, maybe just a local blockchain running on our computer. This blockchain should then be able to have contracts and interact with the contracts, and have contracts interact with each other, such that we can send actions to our contract we have deployed, and maybe it sends, in our case for the auction contract, it sends transfers to the two token contracts, and we should be able to look at the state of all three deployed contracts and then make assertion for them. So we would like to be able to read these states and then make assertions, and we would like to do all of this in an automated way. So automated tests needs a lot of help in the form of we need a locally deployed blockchain where we have all of these factors of such as gas and the interaction between them. We also want to be able to deploy contracts and fail to deploy contracts. We want to do all of these. And we also want to interact with the governance layer of a blockchain. So this is actually something we're working on at Partisia, where we want to make you able to write tests in JUnit, such that you can use the JUnit framework. And here you will be using a local in-process blockchain, such that you can make calls to it and have deployed contracts. And then we're also developing a tool here where you will have code coverage in your Rust contracts using the test in JUnit. So for certainty of behavior, we can do a little bit better in the form of integration testing. We can actually test against something such as a blockchain where the interaction between contracts. And what is necessary to mention here is also that unit testing and integration testing are great tools to working together to make certainty of behavior, because we're actually testing different forms of behavior in the form of we're testing just a single unit, but we're also testing against the system for the whole contract. And in the end, what we can then do is we can actually do something a bit further. We can do what is called formal verification, where we prove that the behavior cannot end up in an ill-defined state where I'm transferring funds I shouldn't be able to transfer, or all of these different forms of conditions we can set. However, this is extremely hard just to do, but it is possible. However, with the blockchain as it is, the state the state space that we need to check is enormous, since that all of the contracts can be, for all of the variables can be in many different states, and we need to check all of it to be certain for no ill-defined behavior. So, however, we can come some of the way in the form of integration and unit testing. So in the end, what you can now do as a developer is you can go and read how to compile and deploy a contract on our testnet, and also maybe learn how to write one. You can also follow the programmer's guide for more reading material. Thank you.